Hey everybody, this is Larry. This is day 27 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and let's look at today's problem, linked list cycle 2. Okay. This is just a linked list cycle thing. Oh, I know one memory. Okay. To get it out of the way, the non-constant memory, the linear memory, for example, is really easy. You just kind of keep track, and then when you see a node that you visited, then you return, right? Not going to do that one because that would be trivial pretty much. But that is actually more applicable for competitive programming. So this may be a little bit trickier for me because it's been a while since I've done problems like this. But the general problem for finding whether you're in a cycle is there's what's it called? A turtle and the hare algorithm, or Freud's cycle detection algorithm, or just like 2 pointers, right? But basically the idea is that you have a fast pointer, you have a slow pointer, and then a fast pointer goes ahead and the slow pointer goes slower, just one step at a time, and the fast one goes 2. So at every time, if it cycles, that if there's no cycles, then the fast would get out of the loop, or the fast pointer would get out of the linked list first, because then it'll be done. Slow pointer will just eventually get out, I suppose. However, if there is a cycle, then the fast pointer would go loop around until eventually the slow pointer gets into the loop, and then because there's a delta of 1 every time, then eventually they'll meet at some place within the loop. And when they meet at some place within the loop, then you know that you have a loop. And also, I think that you can prove that the fast pointer the slow pointer will only go 1 loop at the last loop, right? So actually, I think what I'm going to do is so here's a reminder that I am doing this live, so there might be some awkward pauses. I hope that's okay. What I'm doing right now is bringing up the paintbrush in hopes that it will help. Okay, that looks good enough. Huh. Okay. There we go. Okay. Sorry about that. It's a little bit, but basically you have some pointers, right? Or some nodes, and some pointers that connect the nodes. These are terrible arrows, but let's just say this one, right? And what I was saying is that, so we know that, let's say one of the pointers here and the others, so the slow pointer just entered the loop, right? Then the other pointer could be anywhere. The fast pointer, let's just say, is here, right? So then that means that the distance between these 2 pointers will be, the distance between these 2 nodes would be less than the length of the cycle. So at most, it's going to be cycle minus 1 length away. So that means that in cycle minus 1 time steps, they're going to meet. So that means that they'll always meet when the slow pointer is within the first iteration, right? So that's kind of one thing. Then the other thing is, note that, okay, so let's say now that they meet somewhere in the loop. Let's say they meet here, right? What does that mean? Well, let's see. I'm doing this very ad hoc because this is a very ad hoc problem, so my explanation may be a little sketch. Let me know. But a lot of people made videos on it, so that's okay. But definitely let me know. That means that you have this length is the slower one, and then the faster one would be something like or something like that, right? Not drawn to scale, because I don't know. I didn't really plan it to draw the scale. But okay, right. So what does that mean? That means that we now have enough to draw some formulas, hopefully. But basically, you have this chunk, which is A, say, and we're trying to find A actually, right? Because we want to find the start of the linked list. So the slower pointer would have this chunk, which is B, where the faster pointer would go A. So, well, in total, it will obviously go 2A plus 2B, but that's also equal to A plus B plus some multiples of the cycle, right? So let's just say C and K. So, okay, so now that's enough for me to go back to the browser for a second. So now we have some formulas, right? We have slow pointer moved A plus B steps. Fast pointer moved 2A plus 2B steps. That's by definition because it moved twice, but also fast pointer also moved A plus B plus some K times N, where K is the number of loops. So then we can maybe set them equal to each other. So we kind of subtract these two out. Then we have A plus B is equal to negative K times N. Is that right? And then A is equal to negative K times N plus B. And maybe a clearer way is negative N times K. So because now if we do mod K on both sides, then A mod K, A mod K is equal to, well, this mod cancels out, so it's equal to B, right? Oops. Oh, this is negative, sorry, whoops. Negative B mod K. And it also means that A mod K, maybe I don't need to mod on this side, but because this is a weird notation. But this means that it is, it needs to go to B. Yeah, that means that if we move B steps, then we will catch up. And we can move B steps by resetting A to 0 and then just moving A plus B steps on the slower one, right? And then when they meet, is that right? Did I say that really weird? I think so, but actually this is also, maybe that's how it's a little bit clearer. Just to be clearer, this is because K might be mod K is the same. So then now, what does that mean, right? Well, let's bring back the drawing for a second. Usually when I say that, that means that for us to move, so let's say we meet here still, we change the color again. Let's say we meet here, then here would be K minus B, right? So then now, if we want to meet here, we just we know that in A plus B, we will catch up. We will move the slower pointer A plus B times, but it also means that the distance will be A plus B times, right? So when you kind of when you set that up, you have A is equal to this, and then when you add A plus B on both on the faster pointer, right? Then the gap would have equal to A, right? To come here. that's I think that's roughly it. But I'm trying to see if I can explain that slightly better. But yeah. So basically, okay. So and hope that explanation is good enough. I don't know. But now let's get to the implementation. Not gonna lie, it's probably not that great. But now that we have that intuition and maybe a proof, maybe I recommend watching another video from time to time. But this is me live solving it. But then now we can just implement it. What I like to do is kind of break it down to two pieces: the cycle detecting first, and then the other thing. Let's just do while true. If fast is none, we break. If fast is equal to slow, we break. But at the end, maybe. Because then fast is equal to fast.next. If fast is none, break. Fast is equal to fast.next. Slow is equal to slow.next. Right? And then if fast is none, then we return none. Otherwise, we return, I don't know, let's just return the head for now. And then we could kind of test our, at least test out our cases where there are no loops, so that we can, you know, I kind of think about it like unit testing, where now we're trying to get one case at a time, or TDD. And as you can see, we've got the no cycle cases, which is expected, and also the other answers are expected given out what we do, but not right, obviously. So now, as we said, okay, so now let's say fast is not none. That means that we want to set slow back to the beginning. Do I want to set slow? Yeah. And then we can do while true again. But now we know that fast will not, there is a loop, so we don't have to check the fast is equal to none. So we can just do something like this, and then slow is equal to slow.next. If fast is equal to slow, we break, and then we return. Well, I mean, they're equal, so should be okay either way. Hope I don't have an off by one. Sometimes I do. Well, that's unfortunate. Oh, I guess this check. For some reason, I was thinking about the other case, but we can actually check this first. Just in case that they meet at the very beginning as well. That was definitely one of the cases, but I have an off by one. So sometimes I do have this off by one thing. Yeah, because at the end of this is loop, right? So okay. What am I doing wrong? With index 3, the start is at 1, right? So it goes. Probably have some off by 1 somewhere, but let's see. It goes to 0, 2, 2, 0, 1, right? So it meets here, and then now it goes to the beginning. You go just with 1, Oh, it jumps over it. Huh. Is that right? I guess so, but Man, I'm way awkward on this one. Okay. Oh, whoops. They should now just move B steps, not yeah, okay. Oops. I don't know. I was looking at this one for some reason, I guess. So yeah, so these steps, and then now they would merge together again at the very end. Accepted. This is linear time because we look at each node. At least on the slow pointer, we're gonna look at it linear times, and the fast pointer obviously is also linear because it only moves twice as much as that. Because as we said, we only go for it once. And in terms of space, we only use 2 pointers, so it's gonna be all one space. Not gonna lie, I don't think I did a good job live solving this one. I mean, I think a lot of it is by intuition, but my visualization isn't very helpful. Let me know how you did it. Let me know how we're all doing this together. So yeah, it doesn't really come up competitive, so I have to, but I still should be better about this. So let me know what you think. Let me know how you did, and I will see y'all tomorrow. Bye bye.